Good afternoon. Welcome to the STS-35 post-flight crew press conference. I'd like to introduce to you the commander, Vance Brand, and turn the program over to him.
Thank you, Barbara. Well, it's a pleasure to be back here after a mission that we certainly enjoyed. I'd like to introduce my crew. Guy Gardner, pilot. We have Jeff Hoffman, MS-1. Mike Lounge, MS-2. Bob Parker, MS-3, Sam Durant's PS-1, Ron Parise at the end there, PS-2. We had a big crew. This flight, more than many, demonstrated the value of man in space as a flexible element, as the person who's able to do troubleshooting, to continue on with manual control after automatic systems have failed to perform like we thought they would. So I was just very pleased that we had those capabilities on board to use man as a flexible element. Finally, and most important, I think our mission really demonstrated teamwork. People on the ground here really got with it after we had some space lab failures, and they came up with ways for us to continue, and in the end, through manual pointing, I think our astronomers were approaching, if not equaling, the capabilities of the automatic systems that would have controlled the pointing of the telescopes. Much of the teamwork between the Marshall Space Center, the Johnson Space Center, and us in the crew in orbit came about in a short 12-hour period. Everything was pulled together here on the ground in that short of time to allow us to continue and bring in quite a lot of scientific information. So with that, we'd like to show you our film, and I'll start out with the narration, and then others will chime in. Our patch in Columbia, and Orion is the star field you see there, a very prominent constellation in the northern hemisphere. 7 crew members, Astro mission. This is what our ship looked like as it sat on the pad, and we were having breakfast actually late in the evening. Here we, after having received the weather information, we're in the suit room, getting suited, myself. We have Guy. We have Mike, Sam, Jeff, Ron, and somebody in there. There he is, Bob. Bob was helping a manager adjust his time. 7 crewmen going out to the van. You know, we had a late night or early morning launch, whichever you'd like to call it. So it was a little before midnight as we were going out there.
Here come the main engine ignition, which of course light up about 7 seconds before our liftoff so we can check them out. They stabilize, we pull the umbilical, light the SRBs, and we're off. Here you can see Vance waving to us as you go by the tower. And just a spectacular night launch. I've never seen one. They say they're spectacular to watch, but it certainly is spectacular to watch from inside as well. We managed to launch with almost a full moon, and here's a beautiful shot of us going right by the moon. There was a cloud deck at about 7,000 feet, which you'll see us light up here as we go through it. It was really spectacular to look out the windows and watch that approach. After 2 minutes, the SRBs have consumed their fuel, and we jettison them. Little rockets fire to push them away from the orbiter. And we continue to burn the main engines for a total of about 8.5 minutes, which gets us up to over 17,000 miles an hour, and we're up in orbit around the Earth.
Here we are, finally in orbit about an hour after launch, with a second burn having put us into a circular orbit. Going into orbit to do astronomy has 2 benefits. One, of course, is it gets you above the clouds, but that's not the primary one. The primary one is to get us above the atmosphere itself You see a series of layers of atmosphere sitting above this rather pretty sunset. One of the first things we do on orbit is to begin opening the payload bay doors. This not only exposes the payload so the telescopes can see the stars we came to observe, but also the inner surface of the doors are radiators and allows us to start cooling the vehicle. Once that's accomplished, we began activating first the Space Lab itself with its computers that help us control things. In the payload bay here, you can see some of the elements of our payload. First of all, the X-ray telescope in the far back from the Goddard Space Center, and then here parts of the Space Lab, which was in fact produced in concert with us by the Europeans. Having activated the Space Lab, we proceeded on then to activate the IPS itself with its 3 large telescopes. In fact, once this platform with the telescopes is erected, that's about the last we saw of the X-ray telescope, which is hidden behind this much larger array of telescopes. With the telescopes erected, pointing out the bay towards space, we're now in a position to begin observing. First with the orbiter crew positioning the orbiter. You can actually see a little jet firing here on that frame right there. Once the orbiter crew gets the orbiter pointed in the proper direction, then the mission specialist could, in our case, begin pointing the IPS, the pointing system that had the telescopes, begin pointing it more precisely, sort of fine-tuning towards the exact star or galaxy we're working on. We had troubles with the automatic star trackers doing that, and we resorted to what we call the old-fashioned method of hand guiding. This was done with a lot of help from the ground, which Ron will talk about.
One of the really great things that happened this mission was to watch within one 12-hour shift of bringing up a whole new way of operating, where we had the Johnson Space Center Mission Control Center operating the instrument pointing system, commanding it, and the experimenters at the Payload Operations Control Center in Huntsville commanding the telescopes, and us on board doing the target acquisition and fine guiding. Towards the end of the mission, our efficiency was getting up to the point where we were observing just as many targets as if we had not had the failures. So we and the scientists also were quite pleased with that.
We were divided into 2 teams, a red team and a blue team. This is the blue team getting out of bed in the morning ready to go to work. We tried to maintain a lot of discipline and do everything by the numbers, so we're going to work by the numbers here, floating out of our sleep stations. It was a little crowded down there. These wide-angle views make it seem bigger than it was. It's always fun to experiment in weightlessness with things like bubbles of water here and observe the dynamics of that free-floating fluid. Jeff was a little thirsty, I guess. Mealtime is very important, a chance to relax and recap the events of the day and play with your food a little bit. The school kids we show these to always like those scenes. Some more fluid dynamics experiments. Hygiene is very important. We occasionally took Where does that water go? Just living in the spaceship creates a lot of wastewater, of course. And normally that's held in a storage tank, and every day or so we dump that out into space, which is really a gorgeous sight if you get the sun angle just right. It looks like a snowstorm or a blizzard or a heavy rainstorm. Really spectacular out the window. As you see, we had a little clog in the line that dumped that water overboard, so toward the end of the mission, we rigged up some tubing and were able to transfer that wastewater into storage bags on the inside of the orbiter.
Well, throughout all this problems with the orbiter plumbing, we kept right on trucking as far as the observations and kept getting good science data throughout, and I'd say really all of these problems were no more than a minor inconvenience. We had 4 people on board who have actually, at various times in our careers, have taught in universities. So we took this idea of teachers in space and the interest that NASA has in education, and we actually taught some lessons direct to classrooms on the ground with students. Here's Sam talking about the electromagnetic spectrum, showing why we go into space to see some of the radiation which we can't observe from the ground. And the students on the ground heard this in real time. After Sam finished, I took over to talk a little bit about space operations. We were going to give the students a chance to ask some questions later to Bob and Ron. I guess some of you have heard about my tie in space, which I wanted to demonstrate before the actual lesson. I think it turned out to be a big hit with the students, and hopefully it will inspire some of them to go on and study hard and perhaps go on to do some work in astrophysics or astronautics themselves, because that, of course, is what these projects are all about. The other shift kept on observing while we were teaching this lesson, and here I am showing something about how we observe up on the flight deck. And then after we shifted and took over, these students had a chance to ask questions. It took a lot of work on the part of a lot of people, but I think it was worth it.
Continuing on in the educational vein, one of our midday experiments, the Shuttle Amateur Radio Experiment, or SARX, had as one of its main objectives to allow students at various places around the United States the opportunity to interact directly with the shuttle crew. We talked to 28 groups of students and many other people, just private citizens around the world.
In a lot of ways, this flight was a preview of what's to come in the space station world when we finally get a space station built. I took the time to put together a short demonstration of some of the space station issues. Handling trash is one of the major issues. You saw how we got rid of wastewater by dumping it overboard. However, any solid trash we accumulate, and over the course of 9 days with 7 people, you accumulate a lot of trash. And finding places to stow this trash is always a major problem that gets more important to solve the longer you fly in space. We had a trash compactor experiment here that allowed us to compress the trash by a factor of 3 or 4. And you see Bob extracting this bag of compressed trash in a odor-tight, watertight bag that worked very well and allowed us to store that stuff much more densely.
Well, after several days of really pathfinding ultraviolet observations, it was time to put the instrument pointing system to bed, lower it, and lock it into the payload bay and come home. We were up there to do astronomy, and we could tell from what we had seen that we had reaped an immense harvest of data in ultraviolet astronomy. It was clear from what we saw in the ground that we had a successful scientific mission.
It was time to come home. First of all, we checked out the orbiter systems, started up an APU and cycled the flight controls and checked out all the sensors that we use in re-entering the Earth's atmosphere. And here's a picture you see of the elevons that we're cycling to make sure that they all work properly. This is not to be confused with this is the way we stay up in space by flapping our wings. But we checked all this stuff out the day or so before we came back, and it all worked fine, and we knew we had a good ship for re-entering the Earth's atmosphere after 9 days up in space.
Well, Ron and I were the rookies on this flight, and it's really hard to describe, and certainly to put in words or in video, the feelings that you have when you're watching this. It's really an awesome experience. The first thing you notice is how fast you're going. You're traveling at about 5 miles a second, which takes you 8 or 10 minutes to go all the way across the U.S. And the Earth, as seen from there, is a beautiful place. One of the things we got to do was a lot of nighttime observing. We were an observatory. This moon set here we saw many of those, and at night we had the cabin darkened so that we got a fairly unique view of the dark Earth, because we were dark adapted in the cabin, and we could see the air glow layer at 95 kilometers, and we could see the cities float by with lights. We could see the U.S. about a third of the United States at once as we went over. Well, this is our final sunset on the payload bay before we closed the doors and came home with a very deep, rich harvest of ultraviolet astronomy data.
We landed at night, and so in order to see the shuttle, we used these infrared cameras because the shuttle has no lights on it, and you wouldn't be able to see us at this point otherwise. So this is infrared photography on the outer glide slope. With a heavy orbiter, we came down on glide slope at 17 degrees rather than the 19-degree glide slope of the lighter vehicles. I consider this the most important part of the mission right here, is the pilot gets to lower the landing gear. And then Vance brought it in for just a super smooth landing on the hard surface runway at Edwards, runway 22, right on airspeed, right distance down the runway, just the way it ought to be done. You can see the gear heat up immediately as they touch down here and start glowing white. And this is what it looks like visually. Our families got to watch this from the end of the runway, and so it was just spectacular to not be able to see anything, and all of a sudden this huge shuttle just comes roaring into the field of view. Back to infrared, you can see the hot spots, or the white things you see there. The nose of the orbiter is still pretty hot from its re-entry. And the flames you see on the back, just in front of the vertical tail, are the exhausts from our auxiliary power units, the APUs. And they work by pulsing the hydrazine and turning the motors that keep the hydraulic system powered. And so you see that kind of engine puffy look coming out of the exhaust from the hydrazine. But we rolled out on the runway, and Vance did a great job. Folks came up and said they'd never seen an orbiter that was parked so precisely on the center line of the runway when it came to a wheel stop. The end of just a wonderful mission.
Here we are coming down the stairway. You can see we're pleased to be home. We really enjoyed the trip, but it's always nice to get home. All of us were probably an inch or two taller than normal at that point, having stretched out a bit in weightlessness. Once again, our patch, many people on the crew helped put it together.